Okay, in this video we're going to go over the graph of equations of the form y equals a times parentheses x minus h squared plus k. And we're going to be using some of these terms: parabola, axis of symmetry, vertex, minimum point, and maximum point. So let's look at some examples. So for example, graph y equals x squared. Well, what do we do when we're trying to figure out what the graph of an equation looks like? We plot some points. So let's make a table of x and y, and we just make up some values of x. So how about -3, -2, -1, 0, 1, 2, 3. And what do you get for y for each of these values? Well, -3 in parentheses squared is 9, and then you get 4, 1, 0, 1, 4, 9. And if you plot them, here's the x-axis, here's the y-axis, you get 0, 0. You have -3, 9, so -1, -2, -3, 1, 2, 3. It doesn't have to be perfect. And then maybe a scale of maybe 2, because I want to get to 9. So if I do that, then I'll get to 9 on the top. So -3, 9 is maybe here. Right. So that's -3, 9. And then I also have 3, 9. It's this point. Then I have -2, 4, so that's around here. -2, 4, and I also have 2, 4, just around there. -1, 1, just like here. Oops, well, what happened? -1, 1, 1, 1, and then I have 0, 0. And if I connect the dots with the curve, I get something like this, and it just goes on forever. If I plot in many more points, you're going to get a graph that looks like this. And this kind of shape, which is like a bowl, is called a parabola. There's a precise definition of a parabola that we'll get to. Not every function that looks like a bowl is a parabola. But for the purpose of this video, we're not going to get into those details until later. All right, and one thing you'll notice is that this parabola, if it's drawn very accurately, it's a mirror image of itself across this line. In this case, the line is the y-axis. If you flip like -2, 4 across the line, you get 2, 4, which is also on the graph. So that line is called the axis of symmetry. The axis of symmetry is like the mirror line. And there are also other aspects of the parabola. So there's this lowest point here. This point is called the vertex of the parabola. And the vertex of the parabola, I'll write it down here. The vertex of the parabola is defined to be the point where a parabola intersects its line of symmetry. So there's the axis of symmetry, that's a line, and then there's a vertex, which is a point on the parabola where the parabola meets the line. So that's y equals x squared. And notice that if you plug in negative x and x, you get x squared in both of those. And that explains why the graph is symmetric about the, well, in this case, the axis of symmetry is x equals 0. So let's look at what happens if you have y equals ax squared, where a is not equal to 1. So in the example we did, we have y equals x squared where a is equal to 1, but what happens if a is not equal to 1? Well, if you make some graphs, say this is y equals x squared. If you make a graph of, say, y equals 2x squared, it's going to look something like this. It'll still be curved, but it's going to look twice as steep. To get an idea of why that's true, it helps to make a table of values. So here's x, x squared, and 2x squared. So if x is 0, then x squared and 2x squared are both 0. But if you plug in negative 1 into x squared, you get 1, and then 2x squared is 2 times that, that's 2. In general, 2x squared is always double x squared, right? Because it's just 2 times x squared. So if you plug in negative 2 in for x, you get 4 for x squared and 8 for 2x squared. Plug in negative 3 for x, you get 9 for x squared, and then 18 for 2x squared. And similarly for other values. So if you have a point on y equals x squared, like 1 comma 1, when x is 1, 2x squared is going to be 2. So there's the point 1 comma 1 on x squared, but on y equals 2x squared, there's the point 1 comma 2. So what you're doing to get to x squared is you're doubling the y values. And that explains why the graph is steeper. Because for a given x, your y value now is double what it was before. So it's 2 times higher. What happens if you had y equals 1/3 x squared? Well, if you have 1/3 x squared, it's going to look something like this. If you plot a bunch of points. So what's going on there? Well, what's going on is you're taking 1/3 of the y value. So it looks like the graph is wider, but the way I would think about it, and it's true that it's wider, but I would think about it in terms of the y values as being 1/3 of what they were before, and that's causing the graph to be less steep. So for instance, when x is 1, you would have this point 1 comma 1/3. What happens if you took negative values of a? So for instance, if you did negative x squared, well, y equals negative x squared is going to look like this. It's just a mirror image of y equals x squared. And if you think about what's going on, if you plug in an x value like x equals 1, that gives you 1 comma 1 when y is equal to x squared. but it gives you 1 comma negative 1 when it's y equals negative x squared. So what's going on is that all the y values get multiplied by negative 1, and in terms of the graph, you're flipping the graph across the x-axis. Similarly, if you had y equals negative 2x squared, that's a reflection of y equals x squared about the x-axis. And if you had y equals negative a third x squared, it's a reflection of y equals 1/3 x squared about the x-axis. So this is negative 1/3 x squared, and then this one is y equals negative 2x squared. So one way to summarize what's going on is that if a is positive, the graph opens upward. So you would have a graph where the curve is sort of going up. It's opening up like this. So these are when a is positive. On the other hand, you have a scenario like this where the parabola is opening downward. This is when a is negative, a being the coefficient of x squared. So if a is positive, the graph opens upward, and the vertex is, well, the vertex is the minimum point, the minimum being the lowest point of the graph. So in all the examples that we did, where it's just y equals ax squared, where a is positive, the vertex is 0, 0. On the other hand, if a is negative, then the graph opens downward. And the vertex, well, in the examples that we had, y equals ax squared, the vertex was still 0, 0, but this time, when a is negative, the vertex is the maximum, meaning the highest point of the graph. As you can see in the examples here. In all the examples where a is negative, the graph starts off negative and then it gets less and less negative until it gets to 0, 0 and then becomes negative again. That's what's happening to the y values. Another thing we could observe, so those are two observations. Another thing we could observe is that the smaller the absolute value of a, the less steep the parabola gets. The less steep the parabola. So if you had 1/3 or negative 1/3, the parabola is less steep than if you had y equals x squared or negative x squared. And that's less steep than y equals 2x squared and negative 2x squared. Also, one thing we noticed is that the graphs of y equals ax squared and y equals negative ax squared are reflections across the x-axis. So that's the effect of taking y equals x squared and then multiplying x squared by some constant a. Now what happens if you add something to x squared? So if you had y equals x squared plus k. So if you had y equals x squared plus k, let's look at some examples. So here's y equals x squared. What happens if you had something like y equals x squared plus 2? Well, if you graph y equals x squared plus 2, it looks like this. And what about if you had y equals x squared minus 3? And y equals x squared minus 3, it's going to look something like this. Of course, these are going forever. Well, what's going on is that when you add k to x squared, you are increasing the values of y by k. So to go from x squared to x squared plus 2, you add 2 to x squared. So that's going to shift the graph up by 2 units. So for instance, if you have this point, let's think about what happens if you plug in x equals 1. If you plug in x equals 1 into x squared, you have 1 comma 1. But if you plug in x equals 1 into x squared plus 2, you get 1 comma 3. And 1 comma 3 is 2 units above 1 comma 1. Similarly, if you plug in x equals 1 into x squared minus 3, you get this point 1 comma negative 2, which is 3 units below 1 comma 1. And if you imagine doing that for all the values of x, you'll see that to get from y equals x squared to y equals x squared minus 3, you move down 3 units. So in general, what happens is, by the same reasoning, the graph of y equals ax squared plus k is obtained from the graph of y equals ax squared by shifting the graph of y equals ax squared vertically. And you shift up k units if k is positive, and you shift down, well, if k is negative, right, you wouldn't say that you shift down negative 3, you shift down by 3 units. So that's the absolute value of k. So you shift down the absolute value of k units if k is negative. If you think about it, if k is positive, then k is just the absolute value of k. So either way, it's up or down the absolute value of k units, depending on if k is positive or negative. So that's vertical shifts. Then there's also what happens if you have something like y equals x minus h in parentheses squared. So this time, the x is changing to x minus h, and then you're scoring that. And the question is, what happens? So let's look at the example y equals x squared and y equals x minus 4 in parentheses squared. And the question is, how are their graphs similar or different? Well, for this, we're going to approach things a little differently. Let's make a table of the y values and see what the values of x are going to be in each case. So on the left, I'm going to make a column with y, and then in the middle column, I'm going to have y equals x squared. I'm going to see what x is in that case for the different y's, and then I'm going to make a column for y equals x minus 4 squared. So let's say that y is equal to 25. Well, if y is equal to x squared, what is x? X squared is 25, so what is x? It is either 5 or negative 5, remember we have to not neglect the negative possibility. Now what if y is equal to x minus 4 in parentheses squared? If y is equal to 25, then we have x minus 4 in parentheses squared is 25. What do we get for x? Well, we take square roots of both sides. X minus 4 is either 5 or negative 5. In the first case, we add 4 to both sides. We get 5 plus 4. That's 9. In the second case, we add 4 again. We get negative 5 plus 4. That's negative 1. So when y is 25 and y equals x squared, then x is either 5 or negative 5. But when it's x minus 4 in parentheses squared, y is either, or x is either 9 or negative 1. Now how do those compare? What's the connection between 5 and 9 and negative 5 and negative 1? We added 4 to both sides. And you can see that in this step. In these steps, we added 4. We added 4 on both sides. So actually, the value of x for a given y value increases by 4. Let's do another example just to make sure we understand. So for instance, if y is equal to 16, what are the possibilities of x? Well, if it's y equals x squared, then x squared is 16, then x is either 4 or negative 4. However, if it's x minus 4 in parentheses squared equals 16, then x minus 4 is either 4 or x minus 4 is negative 4. And if x minus 4 is 4, then x is 8. Otherwise, x minus 4 is negative 4, that's x equals 0. And again, notice what happened. When it's x squared equals 16, I get 4 or negative 4. If I add 4, I get the values of x when x minus 4 in parentheses squared is 16. And in general, this is going to happen no matter what y is equal to, because if y is equal to b, so b is some positive or just non-negative number, so it's either positive or 0, then x squared equals b has two solutions, x equals the square root of b or x equals negative the square root of b. But when it's x minus 4 in parentheses squared equals b, then x minus 4 is either the square root of b or negative the square root of b. So my solutions are square root of b plus 4 or negative square root of b plus 4. So how is that going to affect the graphs of y equals x squared and y equals x minus 4 in parentheses squared? So if it's y equals x squared, it looks like this. Okay. But it turns out that y equals x minus 4 in parentheses squared is going to be pretty much the same as y equals x squared, but it's going to be 4 units to the right. And that might seem counterintuitive at first, but if you think about it, if you look at, say, what happens with the vertex, the point 0, 0 is on y equals x squared, because 0 squared is 0. But if you want the vertex of x minus 4 in parentheses squared, it's actually 4 comma 0. And notice that you need to plug in x is equal to 4 in order to get y equals 0. You need to plug in x equals 4 because you have to think about what is going to make x minus 4 equal to 0. And that's when x is 4. So whenever you're solving y equals what x is when y equals b, you end up adding 4 to the value of x. Like here there's a plus 4, you add 4 to the values of x. And that's why you end up shifting to the right by 4 units. You're shifting by 4 units along the x-axis. So horizontal shift by 4 units to the right. Okay. So the way to think about why you shift 4 units to the right is to think about what happens if you have like a y value like, 16, and then solve for x when it's y equals x squared, and then when it's x minus h squared. And you'll see that you end up having to add h to the value of x to make the points match up. So to record what's going on, in general, the graph of y equals a times x minus h squared is obtained from the graph of y equals ax squared by shifting the graph of y equals ax squared horizontally to the right h units if h is positive. So we're looking at the graph of y equals a times x minus h in parentheses squared. So in this example, h was 4 in this example. And we shifted 4 units to the right. What happens if h is negative? If h is negative, then you end up shifting to the left. The absolute value of h units if h is negative. For example, if you had y equals x plus 3 in parentheses squared, that's x minus negative 3 in parentheses squared. And if you look at what happens to the vertex, so in y equals x squared, the vertex is at 0, 0. But what is the vertex of the parabola y equals x plus 3 squared? Well, in order to make y equal to 0, you need x to be negative 3, right? So you have this point negative 3, 0. And similarly, any point on y equals x squared, if it's like a comma a squared, then what you need to make your x is a minus 3. You need your x to be a minus 3 so that the result is y equals a squared. So that explains why the graph shifts 3 units to the left. Horizontal shift 3 units to the left. And notice what happens to the vertex. The vertex gets shifted 3 units to the left also. So that's what happens. And what's the axis of symmetry of this new parabola? The axis of symmetry is x equals negative 3. That's the equation of the line. So let's write down and what we can conclude. So if a parabola has equation y equals a times x minus h squared plus k, then the parabola, well, first of all, it's congruent to the parabola, to the graph of y equals ax squared. Because what you're doing is you're just shifting. To get y equals a times x minus h squared plus k, you start off with y equals ax squared, and then you shift to the right or left by the absolute value of h units, depending on if h is positive or negative, and then you shift up or down. That's the value of k units, depending on if k is positive or negative. And when you're just shifting, you end up with a congruent figure. So that's why this parabola is congruent to the graph of y equals ax squared. And what happens to the vertex? The vertex, well, it was originally 0, 0, and then it gets shifted h units, and then k units up or down. So the vertex is h comma k. Okay. So yeah, do you see why? Because let's just assume that h and k are positive. Okay, then you start off with 0, 0, and then you shift right h units, and then go up k units, so you're at the point h comma k. And a similar reasoning happens if h or k is negative. Like if h is negative 3, then you shift to the left 3 units, so then you're at negative 3. Because you start at 0, you shift 3 to the left, you get negative 3. And similarly for k. And we kind of already wrote this above, but the parabola opens upward and has a minimum point at the vertex h comma k if a is positive, and it opens downward and has a maximum point at h comma k if a is less than 0. And finally, we can say something about the axis of symmetry. As an axis of symmetry with equation x equals h. Because originally the axis of symmetry was x equals 0, and then you're shifting left or right h units. So if you shift right h units, you're at x equals h. That's what happens to the line. And then if h is negative, it's like negative 3, for instance, then you shift 3 to the left, and then your line is x equals negative 3. So it's still x equals h. Okay, we'll do some examples with actual parabolas later, but it's important to understand the general picture of what's going on.